1 mile under the Black Sea, a wooden ship is standing upright in total darkness. Its mast still points at the surface. Rope still hangs from the top. Sailors tied that rope 2,400 years ago. Down there the water is poison, and poison keeps things young. We're going to visit a Greek trader with its cargo still sealed, a Roman wreck nobody has opened, and a drowned world buried under the mud. If this grabs you, hit like and subscribe. Now hold your breath. We're going down. The camera light swings through black water, and something long and straight slides into the frame. It looks wrong. Everything on a deep sea floor is round, lumpy or half buried. Rocks slump. Mud spreads. Nothing stands up straight down here because nothing lasts long enough to stay standing. Yet the shape in the light rises off the bottom like a flagpole, and it keeps going past the top of the picture into the dark. Up on the surface ship, the pilots stop talking. The robot drifts closer and tilts its camera up. It is a mast, wooden, whole, rising about 36 feet off a deck, roughly the height of a 3-story house. Near the top, wrapped around the wood, there is a rope. Real rope. Someone tied it there, pulled it tight, checked the knot, and went back to work. That someone died around 1,500 years ago. Sit with that, because it breaks a rule you probably did not know existed. Wooden ships do not survive on the bottom of the sea, ever. The Titanic went down in 1912, and its steel is already sagging and dripping into orange icicles. Ships lost in the Arctic are softening into mush. Wood in seawater is food, and the ocean is always hungry. So how is this thing still standing? The answer is chemistry, and it is the reason this whole video exists. Around 600 feet below the surface of the Black Sea, the water stops behaving like water. It becomes a trap. Whatever sinks into it gets held exactly as it fell, the way a fly gets held in amber, except this trap is liquid and it fills almost the entire sea. The ship in the light has a name now. Scientists call it Sinop D, after the Turkish town it sank near. It carried clay jars, probably packed with honey or wine or fish sauce, from one port toward another. Then something went wrong. The crew is gone. The ship kept going down. It landed upright. It has been sitting there, deck up, mast up, cargo stacked exactly where the sailors stacked it, through the fall of Rome, through the Middle Ages, through every war and empire and invention that followed. When Columbus set sail, this ship had already spent 1,000 years in the dark. Here is the part that should raise the hair on your arms. There are more. Below that invisible line in the water, the Black Sea holds ships from almost every civilization that ever touched its shore. Greeks, Romans, Byzantines, Ottomans, Cossacks, Venetians. They piled up over thousands of years, sinking one at a time into a place where nothing rots, and they are still down there, parked in the dark like a museum after closing time. Teams have found more than 60 so far. They have barely started. The Black Sea stretches about 600 miles across, wider than the drive from New York to Detroit, and searchers have combed a patch smaller than Rhode Island. Every one of those ships survived for the same reason. To understand it, you first have to meet the creature that eats every other wooden wreck on Earth. It is about as long as your finger. It has destroyed more history than every library fire in the human record. Pull a plank out of warm seawater and snap it in half. The inside looks like a sponge. The tunnels running through it are smooth, round, and lined with something white and hard, like tiny pipes. Follow one to the end and you find the thing that dug it. People call it a shipworm. It is actually a clam that gave up on having a normal shell. Picture a clam that stretched itself into a pale rubbery tube, a foot long, sometimes longer. The two halves of its shell shrank down to the size of a fingernail and moved to the front of its head, where they turned into a drill. The animal presses that drill into wood and rocks it back and forth, a few strokes per second, forever. It swallows the shavings. Bacteria living in its gills break down the sawdust into food. So it eats its own house. It never leaves. It never stops. Now multiply it. A single square foot of sunken timber can hold hundreds of them. They tunnel side by side, careful never to break into each other, until the plank looks solid on the outside and is basically foam on the inside. Then the wood fails all at once. This animal has shaped human history more than most kings. Columbus lost his last ships to it, and got stranded in Jamaica for a year while the hulls quietly turned to lace. In the 1700s it chewed into the wooden walls that held back the sea in the Netherlands, and an entire country nearly drowned because of a clam. Navies burned money coating hulls in tar, in lead, in copper, all to keep this thing out. And when a wooden ship sinks, the shipworms are the funeral. They arrive within weeks. Give them a few years and the hull, the deck, the mast, the oars, the barrels, the crew's shoes, all of it is gone. What survives is pottery, metal and stone, because those things are inedible. That is why our picture of the ancient world looks like marble and clay. We think ancient people built in stone. They built in wood. The wood got eaten. Here is the crack in the story, though. Shipworms need two things. They need salt water and they need oxygen. Take away either one and the drilling stops. The animal suffocates inside its own tunnel. Almost nowhere on Earth offers that escape. The deep ocean is cold and dark and crushing, and it still has oxygen, because water at the poles gets chilled, sinks, and drags a fresh breath of air down with it. That is why the whole seafloor stays breathable. That is why wrecks everywhere else get consumed. Then there is the Black Sea. Deep down in it, the oxygen simply stops. There is a line in the water, invisible, silent, and everything below it is a place where a shipworm dies in minutes. No drilling, no tunnels, no funeral. A ship that crosses that line falls into a room where the wrecking crew cannot follow. So the real question flips around. Instead of asking why these ships survived, we should ask what went wrong with this sea in the first place. The answer starts with a 21-year-old soldier, a rope, and a handful of corks painted white. In 1680, a young Italian named Luigi Marsili anchored a small boat in the middle of the strait at Constantinople and got ready to look like an idiot. He was 21. He was not a professor. He'd come to the city partly as a soldier and partly out of pure nosiness, and he had been listening to the fishermen. They told him something that made no sense. When they dropped their nets deep, the nets bent into an S shape. The top of the net pulled one way, the bottom pulled the other way, the same water at the same moment moving in two opposite directions. Everyone knew the strait flowed south, out of the Black Sea toward the Mediterranean. You can see it from shore. The surface runs like a river, hard enough that ancient sailors had to be dragged upstream by ropes at the sharpest corner. Marsili tied white painted corks along a weighted line at even spacing and lowered it over the side. The shallow corks did exactly what everyone expected. They drifted back toward the stern, riding the surface river south. He kept paying out line. He leaned over the rail and stared down through the green water at the deeper corks glimmering faintly. They were going the other way. Slowly, stubbornly, the deep corks slid forward under the bow of his boat, heading north into the Black Sea. The line took the shape of a bow, streaming out behind him near the top and curving the opposite direction underneath. Two rivers in one channel stacked, sliding past each other in silence. Nobody had ever proved that before. Marsili went home and built a wooden box to explain it. He split the box into two rooms with a divider, cut a hole at the top and a hole at the bottom, filled one side with fresh water and the other with salty water, and opened the holes. The salty water crawled through the bottom hole into the fresh side. The fresh water slid through the top hole the other way. He had built the strait on a tabletop. That is the entire secret, and it is almost embarrassingly simple. Salt water is heavier than fresh water. Heavy sinks, light floats. The Black Sea has huge rivers pouring into it, the Danube and others, dumping fresh water in constantly. That light water piles up and pours out the top of the strait toward the Mediterranean. Meanwhile, the Mediterranean, which is much saltier, pushes back along the bottom of the same narrow channel, crawling north like a cold snake. The strait is thin. In one place the banks squeeze to about half a mile apart, narrower than a lot of American rivers. It is also shallow, a few hundred feet at most. So the salty inflow is a trickle compared to the size of the sea it is feeding. That trickle sinks the moment it arrives, because it is heavy. It settles on the bottom and stays. Marsili thought he had solved a puzzle about currents. He had actually explained why a sea would stop breathing. Fill a glass with soda, then pour honey down the side. The honey sits on the bottom and refuses to blend. Shake it, and it eventually mixes. The Black Sea never gets shaken. Think of it in two layers. On top sits a lighter, fresher layer fed by rivers and rain, roughly the first few hundred feet. Underneath sits a heavy, salty mass that crept in along the bottom of the strait and dropped into the basin like sediment in a jar. Between them there is a boundary where the density changes fast, and that boundary behaves like a physical object. It is a lid. Here is why the lid matters more than anything else in this story. Oxygen only gets into water in two places. It dissolves at the surface, where waves churn air into the top few feet, and plants make it, using sunlight, which reaches only the shallowest layer before the dark swallows it. So all the oxygen in any ocean is manufactured at the top. Everywhere else on the planet, that oxygen gets carried downward. Winter storms mix the surface. Cold water sinks at the poles and slides along the seafloor, taking a lungful of air with it. It takes a few centuries and it circles the entire globe, but the deep sea gets delivered fresh oxygen the way a building gets air pushed through vents. The Black Sea has no vents. The salty deep layer is too heavy for winter storms to flip. Even a brutally cold winter, the kind that chills the surface until it wants to sink, cannot make surface water dense enough to punch through and reach the bottom. Scientists have measured this and confirmed it. The lid holds, so the water down there just sits. Some of it has not touched the sky in centuries. Some of it has sat still for far longer than that, deep in the bottom of the basin, warmed slightly from below by the heat of the Earth itself, turning over so slowly that a full mix takes about 40 years for that layer alone. Now add the corpses. Everything that dies in the sunlit layer sinks. Plankton, fish, leaves wash down the rivers. When that stuff drifts through deeper water, bacteria eat it, and eating burns oxygen. In a normal ocean, no problem, more oxygen arrives. In the Black Sea, the bacteria burn through the supply and nothing replaces it. The oxygen runs out, then it stays out. Roughly 300 feet down, oxygen becomes so scarce that almost nothing familiar can live. There is a strange in-between zone below that, a thin band where there is basically no oxygen and no poison either, a kind of no man's land. Then you cross the last line. Below that, everything you know about the ocean stops applying. No fish, no crabs, no worms, no shipworms, just cold black salt water, absolutely still, holding whatever falls into it. But an empty layer would only slow the rot down. Something else in that water stops it cold. The deep Black Sea is not merely airless. It is chemically loaded, it is toxic, and if you brought a bucket of it to the surface, the smell alone could knock you off your feet. If you could lower a bucket 1,000 feet into the Black Sea and haul it back up, you would want to be standing upwind. The water in that bucket smells like rotten eggs. That smell is a gas called hydrogen sulfide, dissolved into the water the way carbon dioxide is dissolved into soda. In small amounts it is disgusting. In large amounts it shuts down your nervous system. It is the gas that kills people who climb into sewers and manure pits. It works fast enough that victims often fall before they understand something is wrong. The Black Sea holds the largest supply of it on the planet. Here is where it comes from, and the story is grim in a beautiful way. Once the oxygen ran out down there, most life gave up. A few kinds of bacteria did something else. They found a backup plan. Seawater is full of sulfate, a chemical that is basically harmless, and these bacteria learn to breathe it. Where you and I strip oxygen out of air, they strip it out of sulfate molecules instead. They get their energy. And the leftover, the exhaust, the waste product they blow back out into the water, is hydrogen sulfide. They have been doing this without a break for thousands of years. So the poison has been building the entire time. It starts appearing a few hundred feet down, thin at first. It gets stronger the deeper you go. Near the bottom, more than a mile beneath the surface, the concentration level's off at its maximum, and the water there is a still, cold, saturated soup. Now the number that reframes the whole sea. That poisoned water makes up close to 9/10 of everything in the basin. The Black Sea is roughly 600 miles wide and drops over a mile deep in the middle. Nearly all of that volume is a dead zone. The fish, the dolphins, the fishing boats, the beaches, the entire living sea people know, all of it floats on a thin skin of breathable water on top, like the frosting on a very large cake. Under the frosting there is nothing but chemistry. Sailors have always half known this. Pull deep water up in a net and the smell told them something was wrong down there. Old stories talk about the sea being cursed at the bottom. They were closer to the truth than they realized. And a fair question is bothering you right now, because it is the obvious one. If that layer is full of a chemical made by bacteria, then bacteria are alive down there. Bacteria eat things. They are the reason a fallen tree turns into dirt, the reason bread goes green, the reason bodies decay. So why did they leave a wooden ship alone? Why does the poison layer not just rot the wrecks a little slower? Why does it seem to stop the clock completely? That question sat unanswered for a long time, because for most of history nobody could go, look, you cannot dive there. The pressure at 1,000 feet would crush a person, and the poison would finish anything the pressure missed. The answer turned out to be about what those bacteria can and cannot chew, and it explains why a 2,000-year-old plank down there still shows the marks of the tool that cut it. Take an apple and leave it on a counter. In a week, it is brown mush. Now take the same apple, drop it in a jar of syrup and seal the lid. Come back next year and it is still an apple. The deep black sea is the jar. Rotting is a demolition job and demolition takes a crew. On a normal sea floor, that crew is enormous. Shipworms drill, crabs pick. Bacteria that breathe oxygen swarm everything, and they are ferocious eaters because oxygen gives them a huge amount of energy per bite. Fungi move in. Little worms burrow. A sunken ship is a free house made of food, and thousands of species show up to demolish it. Below the poison line, that entire crew is gone. Every animal on the list needs oxygen. Every one of them dies within minutes of crossing the boundary. What is left are the sulfur bacteria, and they are the slowest workers in nature. Breathing sulfate instead of oxygen is a bad deal energetically. It is like running an engine on watered-down fuel. These bacteria get a fraction of the power that oxygen breathers get, so they move slowly, grow slowly, and eat slowly. And they are picky. They mostly feed on soft stuff drifting down from above, dead plankton, sludge, the easy meals. Wood fights back. A tree trunk is built to resist being eaten, because trees spent hundreds of millions of years being attacked. The main ingredient, cellulose, is wrapped in a tough natural glue called lignin, and lignin is genuinely hard to break down. In the oxygen world, certain fungi have cracked the code and can chew straight through it. Those fungi cannot live in the poison layer at all, so a wooden ship falls into a room where the only creatures present are slow, weak, and mostly uninterested in eating wood. The mud helps too. When a hull settles into soft sediment, everything buried gets sealed away from even that trickle of activity, which is why the buried parts of these wrecks come out looking almost new, while the parts standing up in the water column show a little more wear. Add one more thing. It is cold down there, a steady chill just above 40 degrees year-round forever. Cold slows every chemical reaction. It is the same reason your refrigerator works. Put it all together, and you get a place where time barely moves. No animals, no fungi, almost no current. Constant cold, total darkness, chemistry that punishes anything trying to make a living. A ship that sinks into that layer stops aging in any meaningful way. Its wood stays wood, its rope stays rope, its cargo stays sealed. For most of human history, this was a fact sitting in plain sight that nobody connected to anything. Chemists knew the Black Sea was poisoned. Archaeologists knew ancient ships were gone forever. The two groups did not talk. Then, in 1976, one man put the two ideas next to each other on a page and wrote a sentence that should have started a gold rush. Almost nobody listened. It took 24 years for anyone to check. Willard Bascom was an engineer, which is a polite way of saying he liked doing things people said could not be done. He built wave measuring gear in California surf that flattened other people's equipment. He worked on a wild plan to drill a hole through the Earth's crust from a ship. Decades before that was reasonable. He hunted wrecks. He designed machines for reaching places humans could not reach. He wrote books about the ocean that read like adventure stories, because to him that is what it was. In 1976, he published a book about deep water archaeology, and inside it he laid out an idea that was almost too simple to argue with. Ancient ships, he said, are gone because animals ate them. Those animals need oxygen. The Black Sea has no oxygen below a few hundred feet. Therefore the Black Sea should be holding intact ancient ships, right now, in the dark, waiting. That is it. That is the whole argument. A high schooler can follow it. He was writing about a region that had been a highway for 3,000 years. Greeks sailed it to reach their colonies. Romans hauled grain across it. Byzantine merchants crisscrossed it. Vikings came down the rivers into it. Venetians and Genoese fought over its ports. Ottomans ruled it. Every one of those groups lost ships in storms, and every one of those ships went to the same place. Bascom was proposing the greatest archaeological jackpot on Earth, and the field basically shrugged. Part of the problem was that it stayed a thought experiment. Nobody could test it. The wrecks would be sitting in water 1,000 feet deep or more, in a sea where nobody was allowed to poke around freely during the years when this whole region sat behind an iron curtain and warships watched everything that moved. Diving there was impossible. The technology for reaching the bottom with cameras existed only in a handful of Navy programs. Part of the problem was the size. Searching a sea the width of the drive from Chicago to Denver, with equipment that could scan a strip a few hundred feet wide at walking speed, is a joke. You could work for a lifetime and see a fraction of a percent. So Bascom's idea sat on a shelf. Technically brilliant, practically useless. A treasure map with no boat. 24 years went by. The Iron Curtain fell. Cameras got smaller and tougher. Robots got smarter. Sonar got sharper. Deep water stopped being a wall and started being an inconvenience. And in the year 2000, one man had all the right toys and enough nerve to spend an entire expedition season on somebody else's hunch. He had already made his name doing something everyone said was impossible. He had the ships, the funding, the robots, and a reputation that could survive a failure. He also had a second reason for going, and it had nothing to do with shipwrecks. He was chasing something much stranger down there. He was looking for a drowned coastline and a story about a flood. Robert Ballard had a problem that sounds like a joke. He had already found everything. He found the Titanic in 1985 sitting 2.5 miles down in the Atlantic, which made him instantly the most famous ocean explorer alive. Then he found the Bismarck, the German battleship, in even deeper water. Then the Lusitania. Then warships from Guadalcanal, lying in a stretch of seafloor so packed with wrecks that sailors named it Iron Bottom Sound. The man had a habit of pointing at a spot on a map and pulling history out of it. By the year 2000, he had turned his attention to a bigger idea. Instead of hunting famous wrecks, he wanted to prove something about the whole field. Every scrap of ancient seafaring we have came from shallow water, because that is where divers can reach, which means our entire picture of the ancient world at sea comes from ships that sank near land, in the worst weather, on the worst days. It is like judging air travel using only the crashes at the end of the runway. The real story of ancient trade, he argued, is out in the deep, along the routes ships actually took. Nobody had ever looked, because nobody could. So he took a team to the north coast of Turkey, near the town of Sinop, and he brought serious machines with him. Side-scanning sonar to sweep the seafloor with sound. A robot named Argus, a heavy sled built to hang in the deep and take the beating. A smaller robot named Little Hercules tethered to Argus, nimble enough to fly in close and look at things with real cameras. He had 2 goals, and the first one was stranger than the shipwrecks. He was hunting a lost coastline. Some geologists were arguing loudly that this sea had once been a freshwater lake, far smaller and hundreds of feet lower, ringed by people living on its shores. Then, they claimed, the ocean broke in and drowned everything. If that was true, the old beach was still down there, sitting under 100 feet of water, along with whatever those people left behind. His team found signs of it almost immediately. Rounded stones, the kind that only get polished by surf. Snail shells from species that live in fresh water, sitting on a seafloor now covered in salt water. Drowned river valleys carving through the mud where rivers used to run in open air. The second goal was Bascom's hunch. Prove the poison layer preserves ships. To test it properly, they needed a comparison. Find wrecks above the dead zone in normal oxygenated water. Find wrecks below it. Compare. The sonar started painting the seafloor, and the targets started piling up. Hundreds of them. Lumps, ridges, hard spots, anything that bounced sound back a little too crisply. Most would be rocks. Some would be junk. The team started working through the list, dropping robots on target after target, night after night, watching a screen for hours. The first 3 real wrecks they found nearly killed the entire theory. The first one appeared at about 330 feet down, and for a moment it looked like a win. Clay jars, dozens of them, stacked in 2 neat clusters on the mud, the shape unmistakable even through a camera. These were shipping containers of the ancient world, the cardboard boxes of the Mediterranean, and finding them piled in an outline means one thing. A ship sank here, its cargo stayed put, and the hull rotted away around it. The team called it Sinop A. They dated it to the late Roman period, somewhere in the first few centuries after Christ. Then they looked closer, and the mood dropped. The ship itself was basically gone. A few planks stuck up out of the sediment, chewed and eaten and half buried. Everything above the mud line had been consumed. What survived was pottery, because pottery is not food. They moved to the next target. Sinop B, a bigger outline, more jars, a few timbers poking out of the mound. This one they dated later into the Byzantine centuries. Same story, same emptiness where a ship should be. Sinop C looked like a copy of A. 2 mostly buried piles of long carrot-shaped jars, no hull worth the name, 3 wrecks, 3 piles of pots, 0 ships. This is the part of exploration that documentaries skip. You have a limited season, a burn rate measured in thousands of dollars a day, a crew standing watch around the clock, and the evidence coming back tells you that you were wrong. Except Ballard had expected exactly this. All 3 of those wrecks were sitting above the poison line, or right at the edge of it. 330 feet is inside the breathable zone, that water still has some oxygen, which means the shipworms were free to work, and they had worked for centuries with total success. The failures were the control group. They proved the destruction is real. They set the baseline. The theory only lives or dies below the line, and below the line is a different world in every practical sense. The seafloor off Sinop does not slope gently forever. It runs out along a shelf and then drops, hard, plunging away toward water more than half a mile deep. Searching down there is brutally slow. You're dragging equipment through more water, on longer cables, over a bigger area, with less certainty. Every target takes longer to check. The failure rate is punishing. Out of hundreds of sonar hits across these expeditions, only a fraction ever turned into anything identifiable, and plenty of those turned out to be garbage on the seafloor. The season was running out. The team pushed into the deeper water anyway and started chewing through targets. Nothing. Nothing. Rock. Nothing. Then, with barely any time left, they made one more sweep. The sonar drew a shape on the screen that made no sense at all. Everything on a seafloor lies down. This thing was standing up. A sonar image is not a photograph. It is a smear of light and shadow built out of echoes, and reading one takes a trained eye. The target sitting on the screen that night was a thin, hard line with a long shadow trailing behind it. On a flat plane of mud, at 1,000 feet down, something was sticking straight up off the bottom. The team had a guess and did not want to say it out loud. They sent the robots. Argus dropped through the black, hauling its lights and cables. Little Hercules unclipped and flew ahead, and the camera feed climbed up to the control room on the surface ship where people who had been staring at mud for weeks leaned toward the monitor. You already know what they found standing there. What matters is what it meant in that room. The moment that Mast filled the screen, an argument from a book published 24 years earlier stopped being an argument. Bascom's hunch became a measured fact. The Black Sea preserves ancient ships, all of them, everywhere below the line, forever. Little Hercules moved carefully along the hull, mapping what it could see. The ship sat upright in the mud, which is rare and lucky because most wrecks tip over as they fall. Its deck structures were still in place. Its steering gear was there. Its cargo of clay jars sat in the hold where the crew had stowed it. Nothing had scattered. Nothing had collapsed. They needed a date, and dates come from wood. The robot reached in near the steering area and took a small sample, which is the archaeological equivalent of clipping a fingernail. Back on land, a lab measured the radioactive carbon inside it and counted backward. The wood grew in the 5th or 6th century after Christ. To put that in a frame, you can feel this ship was already sitting on that seafloor, when the last Roman emperor in the West lost his throne. It was down there through Charlemagne, through the Crusades, through the printing press, the telescope, the steam engine, the airplane, the moon landing. Above it, empires rose and burned and vanished. It never moved. And the crew is a ghost story with no ending. Nobody knows what happened. There was no battle here, no reef, no shore to smash against. This ship was out in open water, along a working route, doing its job. Then it went down fast enough that nothing spilled. The most likely answer is a storm. This sea has a nasty reputation for them, blowing up out of nothing, kicking short, steep waves that punish small vessels. Ancient sailors called it hostile long before they called it hospitable. The find made headlines. Documentaries followed. The wreck got a name that stuck. Then the archaeologists actually studied the hull, and the celebration went quiet because the ship refused to fit any category they had. The way it was built should have been impossible for its age, or the date should have been wrong, one of the two. Here is how ancient shipbuilders worked, and it is backwards from what you would expect. If you built a boat in your garage today, you would start with a skeleton, set up a spine, add ribs, then nail planks onto the outside as a skin. Frame first, then shell. The Greeks and Romans did the opposite. They built the shell first with no skeleton at all, by locking each plank to its neighbour edge to edge. They cut small slots into the edges of the planks, slid flat wooden tongues into the slots, and pinned them tight with pegs. Plank by plank they grew a hull out of thin air, held together like the world's most patient puzzle. Only afterward did they slide ribs in for support. It was gorgeous work and unbelievably slow. Thousands of hand-cut joints per ship. Archaeologists know this method intimately, because when a Roman wreck is found in shallow water, the joints are the last thing to survive. At some point in the medieval centuries, everyone switched to the modern way, frame first. Cheaper, faster, better for big ships. That switch is one of the biggest technology shifts in maritime history, and here is the embarrassing part. Nobody knows how it happened. We have ships from before, we have ships from after. The middle is a blank, because the ships that would show the transition were built out of wood in exactly the era when nobody was writing manuals about carpentry. This wreck sat right in that blank. 5th or 6th century, exactly when the change was underway. So the team looked for the joints. There were none. No slots, no tongues, no pegs. The old method was simply absent. Then they looked for the other known technique, stitching, where builders literally sew planks together with cord through drilled holes. Some cultures did this for thousands of years. No stitching either, so the planks of this ship are held together by some method that leaves no trace visible from the outside, on a vessel sitting in the exact century where the biggest mystery in ship history lives. It is the single best clue anyone has ever had. And they cannot reach it. The answer is buried. The bulk of the hull is down in the mud, which is the only reason it survived at all. The mud is the preservative. Digging it out means removing the thing holding the ship's shape on timber that has been soaked for 1,500 years and has the structural strength of wet cardboard. You could excavate it, once, badly, and destroy it. There was another puzzle standing right in front of the cameras too. That mast pointing at the surface was originally read as evidence for one type of sail, which would have been the earliest example ever found and rewritten another chapter of history. Then a return trip took a harder look at where the mast sat on the deck, and the whole interpretation fell apart. They went back in 2003, then again in 2007. The second look at that mast changed the story. It was leaning forward, mounted near the bow, and a mast in that position usually is not the main mast at all. It is a smaller forward mast that ancient sailors used for steering help and extra pull, angled out over the front of the ship like a bowsprit, which means the main mast is missing, which means this ship was bigger and more complicated than the first read suggested, which means the sail question that got everyone excited is now wide open again. Every answer down there generates 2 more questions. That is the pattern. The bigger prize was the cargo, because a ship's cargo is a message from a dead economy. Those long jars stacked in the hold were made locally, in the region around this coast, which tells you the ship was working a regional trade route, instead of hauling luxury goods from far away. This was a truck, not a treasure ship, so the team brought a few jars up. Think about what that means. A container sealed by hand, loaded onto a boat, sunk, and left in cold black chemical stillness for a millennium and a half. Then a robot arm picks it up and carries it into the sunlight. Some of them may have held honey, sit with that, because honey is the most stubborn food humans have. Archaeologists have pulled honey out of ancient tombs that was still, technically, honey. It resists spoiling because it is too sweet and too dry for bacteria to survive in, which is the same trick the Deep Black Sea plays with poison instead of sugar. This coast was famous for it. Ancient writers complained about the honey from this region, claiming some of it was mildly toxic because of the flowers the bees fed on, and there is a story about an army getting stumbling drunk on it. Whether that is what these jars carried is unproven. Other candidates are wine, olive oil and fish sauce, which was the ketchup of the ancient world and smelled like a crime scene. The team mapped the wreck with sound, built rough three-dimensional models from overlapping photos, and made a decision that defines this entire field. Leave it, not because of laziness, because of arithmetic. Excavating a fragile deep wreck properly costs a fortune and takes years, and the moment you expose that wood, you start a clock you cannot stop. Waterlogged ancient timber, brought into air, warps and cracks and shrinks into garbage, unless you spend a decade soaking it in chemicals and freeze-drying it. Sweden did that with one famous warship, and it took nearly 30 years. So the ship stays, safe, cold, and out of reach. Meanwhile, one detail from those shallow failed wrecks kept nagging at the team. Synop A, B and C should have been stripped bare. Some of their wood was still there. Something was reaching up the slope and touching them, and it was coming from below. Picture the boundary between the two layers as a rubber sheet stretched across the whole sea, hundreds of feet down. It is not flat. It flexes. When water of two different densities sits stacked like this, the surface between them behaves the way the top of a pond does. It can carry waves, real waves, with crests and troughs, rolling for miles. They just roll along a boundary buried deep inside the sea instead of the one you can see. Scientists call them internal waves, and they are enormous. Waves on the surface of the ocean might run 6 or 10 feet from trough to crest. Internal waves can be 100 feet tall or more, moving slowly through the dark, and you would never know one passed under your boat. Something has to shove them into motion. In this sea, plenty does. Storms hammer the surface, and the energy punches downward. Rivers surge after rain and dump cold water off their mouths. That salty inflow from the strait keeps crawling in along the bottom and slopping around. All of it transmits energy into the boundary layer, and the rubber sheet starts rippling. Now put a shelf under it. The seafloor near shore is shallow, then it plunges off a rim into the deep. The poison boundary intersects that slope somewhere, and internal waves rolling in from the deep basin break against it, the way ocean waves break on a beach. Except this beach is 300 feet underwater and the surf is made of dead, oxygen-free water. Every time one of those waves washes up the slope, it drags a tongue of poison layer with it. For hours, wrecks that normally sit in breathable water get submerged in something lethal. Then the water pulls back and the oxygen returns. For a shipworm, that is a nightmare. Suffocation, then relief, then suffocation. It cannot settle in and eat properly. That is the leading explanation for why those shallow Synop wrecks kept a few planks when they should have kept none. They are living in a zone that flickers. This matters far more than it sounds. If the poison sloshes, the boundary is not a hard line at all. It is a blurry breathing edge, and wrecks might survive at depths where nobody thought to look. It also means the preservation zone changes over the centuries, which means some wrecks got a few good centuries and some got eaten. It also means something less comforting. If the boundary can move up the slope for a few hours, the question of whether it can move up permanently becomes real, and that question is now sitting in front of scientists who study this sea for a living. Hold that thought, because it comes back at the end of this story and it is worse than you think. For now, follow a different team, working a different coast, in a different decade, with better toys. They were not looking for ships at all. They were looking for a drowned world, and they found a graveyard by accident. In 2015, a survey ship called the Stril Explorer started working slow lines back and forth off the coast of Bulgaria. She was built for the oil business. Long, unglamorous, packed with equipment that exists to find pipelines and inspect drilling gear on the seafloor, and equipped with the kind of positioning system that can hold a ship in one spot in a gale. Nobody puts a boat like this on television. The team aboard came from a university in England, led by an archaeologist named John Adams, and they had a question that had almost nothing to do with wrecks. They wanted to know when the sea drowned its own coastline. At the peak of the last ice age, the world's water was locked in glaciers, and the oceans stood hundreds of feet lower. This basin was a lake, cut off from the ocean, its shore way out where deep water is now. As the ice melted, water rose everywhere. The old coast went under. The thing is, people lived on that coast. They were fishing, farming, building. Whatever they had is still out there, buried under mud and salt water, along with the actual beach they walked on. Adams wanted to map it. Where was the shoreline? When did it flood? How fast? And what happened to the people who watched the water come? Answering that means mapping the seafloor in obsessive detail across a huge area. Sound waves for the shape of the bottom, different sound waves that punch into the mud and reveal the layers beneath. Cores of sediment pulled up and red like tree rings. It is grinding, methodical, unromantic science. They surveyed something like 770 square miles of seabed across 3 seasons. That is bigger than the entire state of Rhode Island, mapped in high resolution, line by line, hour after hour. And when you scan that much ground with instruments that's sharp, you find things that are not on your list. Ships started appearing in the data. Not 1, not 5. The team called them a bonus, which is one of the great understatements in modern archaeology, because the bonus turned out to be the biggest haul of preserved wrecks anyone has ever found in one place. They had one advantage Ballard never had. Technology had moved again. Their main robot could fly along the seafloor at several times the speed of older machines, scanning as it went, covering ground fast enough to make a survey like this affordable. A second robot carried camera arrays for close inspection, so they did something nobody had ever done. Instead of finding one wreck and studying it for a decade, they started collecting wrecks the way you collect trading cards. The first count was over 40. The final count from the project climbed past 60. Ships from 1,000 years of history, sitting side by side in the dark, and one of them was about to make everyone on that boat stop breathing. Start with the range of it, because the range is the point. Down there, within a patch of seafloor smaller than a lot of American counties, the team found ships from almost every era this sea has known. Byzantine traders, hauling goods for an empire that ran from these shores to Italy. Ottoman merchant vessels from the centuries when this was a Turkish lake, and Istanbul was the richest city in the world. A cluster of small raiding boats from the 1700s, the kind used by Cossacks, who were essentially the pirates of this coast and terrified everyone with fast shallow craft that could vanish up a river. There was a medieval Italian trading ship sitting more than half a mile down, mast still standing, quarterdeck still in place. That type of vessel is written about constantly in medieval documents and had never been seen. It was the most complete example of its kind on Earth the moment the camera found it. Line them up in your head as a timeline. Every one of these ships was built by people who learned from the people before them. The Byzantine hull teaches you something that shows up modified in the Italian hull, which shows up again in the Ottoman one. Techniques passing from hand to hand across 1,000 years, and here they all are in one place at the same time in condition good enough to compare directly. That has never existed before. Anywhere, in any field. Most of these ships have something else in common, and it changes how you picture the people aboard. They sank far out, not near rocks, not near harbours, out in open water, along the routes ships actually used, dozens of miles from any land, which means these were not clumsy accidents in the shallows. These crews were caught by weather in the middle of a crossing, with no chance of swimming anywhere. That tells you something about ancient sailors that history books gloss over. They were crossing open water routinely, out of sight of land, in boats you would hesitate to take out on a lake. They knew the risk. This sea is famous for storms that build in hours. They went anyway, because that is where the money was, season after season, generation after generation. Every wreck down there is a business trip that ended, and the team was seeing all of this without touching a thing. That is the second revolution in this story, and it deserves its own chapter, because the way they recorded these ships would have sounded like magic to Ballard's team 15 years earlier. They were building perfect copies of the wrecks, copies you can spin around on a laptop, zoom into, measure, and hand to any archaeologist on the planet. Copies detailed enough that you can see where the shipwright's tool slipped. Here is the trick, and you have probably used a version of it without knowing. Take 100 photographs of an object from 100 angles. Feed them to software. The software finds the same point in multiple pictures, works out where the camera must have been standing each time, and uses that to calculate exactly where that point sits in space. Do it for millions of points, and you get a three-dimensional model built out of nothing but photographs. It is called photogrammetry, and it is the same math your brain runs with two eyes. The team just used a robot with better eyes and far more patience. Their machines flew slow grids over each wreck, cameras firing constantly, lights blazing into water that has been pitch black since forever. Across the project, they shot something like 250,000 photographs. Then the models came together on screen, and people got quiet. You can see chisel marks. Read that again. On a ship that sank centuries ago, the software resolves the fine cuts left by the tool that shaped the wood. That is the individual working of one carpenter, one afternoon, on a beach somewhere, preserved and now measurable. Nothing about that is normal. In regular underwater archaeology, you are lucky to get a shape. Usually you get a pile and a lot of guessing. The models let you do things that were impossible before. You can measure a hull without a tape measure. You can compare two ships built 400 years apart down to the millimeter, sitting side by side in a computer. You can hand the model to a specialist in another country and let them examine a wreck they will never visit. Most importantly, you take nothing. Nothing gets lifted, disturbed, or exposed. The ship stays exactly where it has been, in the only environment that will preserve it, and the science happens on a laptop. That is a complete reversal of how archaeology worked for 2 centuries. The old way was dig it up, drag it home, put it in a case. The new way is leave it, copy it, study the copy. The Black Sea forced that shift because it left no choice. These wrecks are too deep for divers, too fragile to lift, and too numerous to ever excavate. The only reasonable option is to look and walk away. And when you look at the images this project produced, one wreck grabs you and refuses to let go. It is an Ottoman ship. Somebody spent real time carving decorations into the arm the helmsman used to steer with. Nobody sees that part of a ship except the person holding it, which means a craftsman put art into a piece of wood that only one working sailor would ever touch, and then the sea kept it for him. The image loads and your brain files it as a museum reconstruction. Then you notice the mud. An Ottoman merchant ship lies on the seabed, and the back end of it is almost embarrassingly intact. There is the tiller, the long wooden arm the helmsman gripped to steer, still connected to the rudder. Along it, someone carved decoration. Curves and patterns cut into a working part of a working boat. Think about who that was for. Nobody admires a tiller. Passengers never see it. Merchants loading cargo never look at it. The only human being who touches that piece of wood is the sailor holding it for hours in the cold, staring ahead, keeping the bow where it belongs. Somebody in a shipyard decided that person deserved something nice to hold. That carver has been dead for centuries. His name is gone. His town is probably gone. The thing he made with his hands is sitting in the dark, sharp enough that a camera can read his cuts. Then look at the deck. There is rope on it, coiled, lying where it was left. Nothing about that is a small detail. Rope is the first thing to vanish from a wreck anywhere else on Earth. It is plant fibre, which is basically a snack. In normal seawater, rope is gone within a season, along with sails, baskets, clothing, food, and every soft thing that made a ship a place where people lived. What survives elsewhere is the skeleton. The Black Sea keeps the flesh. So we get the tiny stuff. The stuff nobody records in a document because it is too ordinary to mention. A coil of rope tells you the crew's habits, where they stowed gear, how they wound a line, whether the deck was tidy or a mess when everything went wrong. That coil is a photograph of a Tuesday, and the way it is sitting, undisturbed, tells you how this ship died. It went down without a fight. No fire, no long slow flooding with the crew tearing the deck apart trying to save themselves. Something happened fast. The ship went under, and the sea carried it down gently enough that a loose coil of rope stayed put. Now hold 2 pictures in your head at once. Picture 1, the seafloor, a finished object, a perfect, silent, 3-dimensional record. Picture 2, the deck of that same ship on the surface, in weather, with men on it. They knew each other. Someone was cursing. Someone was probably scared and hiding it. They had families in a port somewhere who kept waiting after the ship stopped coming. That second picture is the thing the deep Black Sea does that no other site can. it collapses the distance. Archaeology usually gives you fragments, and your imagination has to do the heavy lifting. Here, the sea hands you the actual scene, right down to the rope, and your imagination has nothing left to do except put the people back on the deck. This is why researchers on that expedition describe the feeling as stepping backward through time when the lights hit a hull. It is a physical sensation, apparently, a wrongness. Your eyes report a fresh object and your brain rejects the date. They mapped ship after ship this way, cataloguing centuries. Then, in the last season, their sonar found something more than a mile down, and every ship in this story so far became a warm-up act. The wood on that seafloor grew before Alexander the Great was born. It was the last season, the summer of 2017, and the survey had already made its name. The sonar was working deep water now, out where the seafloor sits more than a mile below the keel. That is Titanic territory. It is a place where a dropped wrench takes half an hour to land. A shape came back off the bottom, and the shape had a spine. Wrecks in sonar usually look like rubble. This one had a long clean line with a raised end, and something standing off it. The team sent the robots down through more than 6,000 feet of water, which is a slow, tense, unglamorous descent. The cable pays out, the depth number climbs, nobody says much. Then the lights found it. A ship, lying on its side 75 feet long, which is about the length of 2 school buses parked end to end. Its hull was closed, its rudder was attached, its mast was there. Inside, along the length of it, the benches were still fixed where rowers had sat. One researcher on that team described the moment as looking into another world, and said the thing appears out of the dark so perfectly preserved that it feels like stepping back in time. Look at what that list actually contains, because every item on it is a small impossibility. A rudder is a thin blade hung off the side. It should have snapped or drifted off. Still there. A mast is a long lever with the whole weight of rigging pulling on it. It should have gone over the side on the way down, standing. Rowing benches are light interior furniture. In any other wreck, they vanish first, along with the deck, the hatches, and everything else that makes a boat feel like a place. They're exactly where the carpenter put them. Nobody in this field had ever seen a ship this old with its inside still installed. Ancient vessels come to us as an outline of pottery and a bad mood. This one came as a ship. The style told the archaeologists immediately what they were looking at. A merchant trader built to haul cargo across open water, of a kind used by Greek city-states running goods out to their colonies scattered around this coast. Those colonies were real cities with real appetites, and the whole reason this sea has so many wrecks is that somebody had to feed them. So a Greek ship working a route went down in weather, dropped a mile through the dark and landed on the one seafloor in the world that would keep it. The lead archaeologist on the project said afterward that a ship surviving intact from the classical world, in over a mile of water, was something he would never have believed possible. He had spent his career believing it was impossible. Then he was looking at it. They had a hunch about the age from the shape alone, and the hunch was aggressive. To check it, they needed to take a piece, and when the number came back, the team realised this ship had a twin, painted on the side of a wine cup sitting in a glass case in London. Go to the British Museum and find a large clay vessel painted black and orange. The scene wrapped around it shows a boat on a stylised sea. The mast is up, the sail is set. Men are rowing. Tied to the mast is a man, and above him, circling on wings, are creatures with women's faces. It is the scene from the Odyssey, the one everybody half remembers. The hero wants to hear the sirens sing, knowing the song drives men to steer into the rocks. So he plugs his crew's ears with wax and orders them to lash him to the mast and ignore every command he gives. The painter who made that vase never saw Odysseus. He was working centuries after the story was old. So when he needed to draw a ship, he did what any artist does. He drew the ships he saw in the harbour. That is the entire point, and it is the reason this vase matters more than the myth on it. For a long time, painted pottery like this was one of our best sources on what ancient ships looked like. Think about how bad that is. Imagine reconstructing an aircraft carrier from cartoons on a coffee mug. Artists simplify. They exaggerate. They leave things out because the picture needs room for the story. Scholars argued for decades over whether a detail on a vase was real engineering or artistic decoration. Now put the wreck next to it. The ship a mile under the Black Sea matches the vessel on that verse closely. Same general build, same arrangement, same kind of trading craft, which does two things at once. It confirms the wreck. The archaeologists knew what they were seeing because they had seen its portrait already. And it confirms the vase. That painter was accurate. Suddenly every other Greek ship painted on every other pot becomes better evidence than it was yesterday, because we finally have one real example to check the artist against, and the artist passed. That is a strange kind of time travel. A man painted a ship because he needed a background for a monster story. 24 centuries later, the ship in his background is the thing we care about, and the real version of it is sitting in the dark waiting to be compared to his brushwork. There is a detail worth being honest about here, since plenty of headlines got it wrong. This wreck has no connection to Odysseus. The story it decorates is set far earlier than the ship in the picture, and the wreck itself is later still. The match is about shipbuilding, and shipbuilding is the better story anyway. The team had the shape, the style, and the vase. What they did not have was proof. So a robot the size of a car reached down through a mile of poison and clipped off a piece of a ship, and a laboratory started counting atoms. Here is how you weigh time. The air around you contains a rare, unstable version of carbon. It gets made constantly, high in the atmosphere, when radiation from space smashes into gas. Plants pull carbon out of the air to build themselves and take in that rare version, along with the normal kind, in the same proportion the air has. A tree grows. Its wood is now loaded with both types mixed at the atmosphere's ratio. Then the tree gets cut down, sawn into planks, built into a hull, and the moment it stopped growing, it stopped taking in new carbon. The clock started. The normal carbon in that plank sits there forever. The unstable kind falls apart, slowly, steadily, atom by atom at a rate nothing can speed up or slow down. Not heat, not pressure, not chemistry. Cook it, freeze it, drop it in a poisoned sea for 100 generations, and the decay rate does not flinch. Every 5,700 years or so, half of it is gone. So you take a sample, measure how much of the unstable carbon is left compared to the normal kind, and do the arithmetic backward. Less of it means older. It is a stopwatch that starts the day a plant dies, and it works out to about 50,000 years back before there is too little left to read. The robots took a small piece from this wreck, brought it up through a mile of water, and handed it to a lab. The answer came back near 400 years before Christ, 24 centuries. Let that arrange itself into a shape you can hold. When this ship sank, Socrates had recently been executed in Athens. The Parthenon was a fairly new building. Rome was a scrappy town that had never fought a war outside Italy. Alexander the Great had not been born, and would not be for decades. The ship went down. Egypt still had pharaohs. Rome rose, conquered everything, split in half and fell. The Middle Ages came and went. Gunpowder arrived. Ships crossed the Atlantic. Electricity, antibiotics, nuclear weapons. Somebody walked on the moon. The whole time the mast stayed up. With that number, the announcement became official and the record fell. The oldest intact shipwreck ever found by human beings. Not the oldest wreck since older pottery piles exist. The oldest one that is still a ship. The story went around the world. A documentary premiered at the British Museum, a short walk from that painted vase. And in every article, buried near the bottom, was one line that should have been the headline. The hold is still sealed. Nobody has looked inside. Normally a cargo hold is the easy part. When an ancient ship rots away, the cargo spills onto the mud and lies there in the open. That is what those Sinop pottery piles were. Archaeologists arrive, look at the jars and read the ship's biography off them like a shipping label. Jar shapes were regional. A trained eye can look at a curve and a handle and say which town made it and roughly what decade. So the standard move is simple. Find the pile, identify the jars, know the route. That move is unavailable here, and the reason is almost funny. The ship is too well preserved, the hull is closed, the decking is on, the hold is exactly as intact as everything else, which means the cargo is inside a sealed wooden box, and the box has been shut since 400 years before Christ. One researcher put it plainly. Usually they find the jars and can guess where a ship came from. With this one, everything is still in the hold. Every other archaeologist on Earth would trade a limb for that problem. Think about what a sealed container means in this specific sea. Outside the hull, you have the deep water preserving everything by being cold, dark, still, and chemically hostile to life. Inside the hull, you have that same water, plus a physical barrier keeping out even the faint drift of sediment and the slow bacterial nibbling that reaches exposed surfaces. It is a vault inside a vault. And this was a working merchant ship, which means the hold was full when it went down. That is the entire reason the voyage existed. Somebody paid for that cargo, hired that crew, and was waiting at a port that never got its delivery. So what is in there? The honest answer is that nobody knows, and the researchers say so. Jars are the safe bet, filled with wine or oil or grain from the Mediterranean world, headed for Greek colonies that could not grow enough of their own. Those colonies survived on imports and shipped grain back the other way, and that trade fed Athens itself. But a merchant ship carried more than its main cargo. There were personal belongings, tools, cooking gear, the crew's food, whatever small things they were selling on the side. And in a place where rope survives, all of that survives. Then a specialist from a major research institution said the thing that made archaeologists sit up, and it went past ordinary treasure entirely. He suggested you might find books down there, parchment, written documents, words, written by hand, in ink, by someone standing on a dock in the ancient world. Here is why that suggestion is nearly unbearable. We have lost almost everything the ancient world wrote. That is not an exaggeration. It is an accounting. Take the Greek playwrights everybody studies in school. One of them wrote around 90 plays, 7 survive. Another wrote more than 120, 7 survive. Whole libraries of history, science, medicine, poetry, letters, and mathematics existed, were read, were copied, and are now gone. What we have is the tiny fraction that somebody kept recopying by hand, century after century, until printing arrived and locked it in place. Everything else burned, rotted, got scraped clean for reuse, or fell apart. Paper and parchment are organic. They are the most fragile things humans make. They need dry, stable, protected storage, and the ancient world provided that almost nowhere. The exceptions are famous precisely because they are freaks. Bone-dry sand in Egypt, charred lumps buried under volcanic ash near Naples, so cooked that we needed particle accelerators and artificial intelligence to read them. Now consider the deep Black Sea, no oxygen, no light, steady cold, no animals, no fungi, total stillness. And inside a sealed hold, no current at all. Those are storage conditions a National Archive would envy. Nobody is claiming there are books on this particular ship. That is a possibility, raised by a serious person, based on a real principle. Documents travelled with cargo, merchants kept records, ships carried mail, orders, receipts, lists. A trading vessel with a sealed hold in a place where rope survives is a plausible container for writing, and plausible is more than this field has ever had before. Understand the scale of what that would mean. Every ancient text we possess reached us through a chain of copyists, each with opinions, mistakes, and reasons to leave things out. We are reading photocopies of photocopies. A document straight off a ship would skip the entire chain. It would be a voice with nothing between it and you. And there is a second layer to this, quieter and stranger. Books are the dramatic version. The realistic version is more human. A sailor's belongings, a wooden bowl with teeth marks on the rim, a sandal, a packet of food, a carved toy someone was bringing home. Those things exist nowhere else on Earth from this period, because they were made of the materials that always disappear. So the hold might be an archive, and it might be a lunchbox, and both would rewrite something. There is one enormous problem, and it is the reason this chapter has no ending. They left it there, and they may never come back. The obvious question is why anyone would find that ship and simply leave. Start with the money, because it is the least romantic reason and the most decisive one. That survey happened because a private foundation paid for it. Deep water work runs on ships that cost a fortune per day, robots that cost more, and crews working around the clock. When the funding ended, the ships went back to the oil industry, and the team said publicly that going back to the wreck would take more money than they had. So the world's oldest intact ship is sitting there partly because the invoice was too high. Then there is the harder reason. Opening that hold means excavating it, and excavating means taking things out and bringing them into air. That is where the horror show begins. Ancient waterlogged wood looks solid. It is a lie. Over centuries, the internal structure of the wood dissolves away and water moves into the empty space. What you have is a wooden-shaped sponge holding its form because it is full of liquid. Lift it out and the water starts leaving. As it goes, the surface tension inside the cells pulls the walls together and the object shrinks, twists, splits and curls into unrecognizable garbage. It can happen in days. The famous rescue is a Swedish warship raised from a harbour decades ago. Saving that ship meant spraying it with chemicals to replace the water inside the wood, and that spraying went on for years, followed by years more of drying. It took roughly 3 decades, and it is still an ongoing engineering problem today, with a whole building and a staff dedicated to keeping it from sagging. That was one ship from shallow water in a country that decided to make it a national project. Now apply that to a wreck a mile down, in a sea shared by several nations, at a site that would need years of robot work just to document properly before a single timber moved. The team made the only sane call. They said the ship is preserved, it is safe, it is stable, and it is unlikely to attract treasure hunters. That last part carries weight. They never released the exact location, and depth is its own security guard. A mile of water keeps out every diver on the planet and every amateur with a boat. So the ship stays, cold, dark, sealed, and safer than anything in a museum, which leaves an uncomfortable truth to sit with. The greatest archaeological find of the century is finished being studied for now, and the answer to what is in the hold may not arrive in your lifetime. Meanwhile, the same survey that found it kept scanning, and the data showed something under the seafloor that had nothing to do with ships. There was a coastline down there, with a settlement on it. Turn the sonar around and aim it into the mud instead of at it. Certain sound waves punch through sediment and bounce off the layers underneath, drawing a picture of what the seafloor looked like before it was the seafloor. That is what the survey was built to do. The ships were the distraction. This was the mission. And the picture that came back is a landscape. There are river valleys down there, real ones, carved by water running in open air, winding across ground that is now under salt water. There are old shorelines, marked by stones rounded and polished the way stones only get when surf rolls them for years. Ballard's team on the Turkish coast found the same thing, plus something that ends the argument: snail shells, from species that live only in fresh water, sitting on a seabed now covered by a salty sea. Freshwater snails do not commute. They do not wash out to sea and settle politely in rows. Their shells are there because they lived there, in a lake, on a shore, breathing air above them. So the geology says it plainly. This sea was a lake. Its shore was hundreds of feet lower than today and miles further out. Then the survey team, working off the Bulgarian coast, found the part that turns geology into a human story: a settlement. It sits near the mouth of a river, in a sheltered spot, and it dates to the early Bronze Age. That location was a good harbour for thousands of years afterward. Greeks used it, Byzantines used it, Ottomans used it. Sailors kept recognising it as the right place to pull in, generation after generation, long after the original people were forgotten. Now scale it up in your head. If people lived at that spot, people lived along the entire old coastline. That is hundreds of miles of shore, and prehistoric people always settled the coast, because the coast is where the food is. Fish, shellfish, fresh water from the rivers, flat ground, easy travel. All of it is underwater now. Every village, every camp, every fishing spot, every scrap those people ever dropped. And here is where two halves of this story finally lock together. The old shoreline sits at a depth of roughly 300 to 400 feet, depending where you measure. That is right around the poison boundary, which means the drowned coast is partly inside the zone where nothing rots. Think about what that could mean. Wooden houses, baskets, dugout canoes, fish traps, wooden tools, the entire soft world of prehistoric life, the 90% of it that has never survived anywhere, potentially sitting in the dark alongside the ships. Nobody has proven that yet. The mud has to be cooperating, and the poison has to have reached the right places at the right time. But it puts the biggest question in this whole story on the table, and it is a question people have fought over for 30 years. How fast did the water come? Because if it came slowly, those people packed up and walked inland, and there is nothing down there but empty ground. And if it came fast, the coast is a crime scene. In 1997, 2 geologists from Columbia University published an idea and then a book, and the book had a title that guaranteed a fight. William Ryan and Walter Pittman argued this. The Black Sea was a freshwater lake, sitting far below the level of the world ocean, sealed off from the Mediterranean by a ridge of land where the strait is today. That ridge worked as a dam. Behind it, the lake sat low and quiet with people living around its edge, farming and fishing on ground that today is under hundreds of feet of water. Meanwhile, the Ice Age was ending. The ocean outside was rising. Year after year, century after century, the water on the far side of that dam climbed. Then it reached the top. Their scenario is violent. The water spills over, and spilling water cuts. It carves into the ridge, and the deeper it cuts, the more water comes through, and the more water comes through, the faster it cuts. A trickle becomes a stream, becomes a torrent, becomes a canyon. The dam does not slowly leak, it unzips. By their estimate, the flow through that gap hit a force comparable to a couple hundred Niagara Falls, roaring through a gorge and thundering down into a basin that was hundreds of feet lower. They calculated the lake rising 6 inches a day. Every day. For months, 6 inches sounds gentle until you look at a map. That shoreline was flat. Flat ground means water does not rise up, it races sideways. The shore would advance across the landscape at speeds people could watch. Fields gone in a week. A village that was inland becomes waterfront and then becomes lake bottom. There is no negotiating with that. You take what you can carry and you keep walking, and next year you walk again. They put a date on it. Around 7,600 years ago, later revised earlier by their own team, and then they said the thing that put it on television. The people who watched this happen would have told their children. Their children would have told theirs. A story about the day the sea came over the hills and drowned the world would travel with those refugees as they scattered into Europe and Asia, and it would keep travelling, changing shape for thousands of years, which would make this the event behind the flood myths. Noah, the Mesopotamian versions that came earlier, the dozens of others, scientists proposing the actual origin of the actual Noah story. It was irresistible. Documentaries, magazine covers, lectures, arguments at dinner tables. Their evidence was real too. Cores of mud from the seafloor showing a hard, sudden switch from freshwater shellfish to saltwater shellfish right at that date. One layer lake, next layer sea. Then the rest of the field showed up with their own cores, and they came for it hard. The critics did not argue that the sea stayed a lake. Everyone agrees the water came in. The fight is about the speed, and the speed changes everything. Their model is boring, which in science is usually a compliment. Picture the strait as a two-way channel rather than a dam. Fresh water from the lake pours out along the top, heading for the Mediterranean, because the lake is fed by enormous rivers and has more water than it can hold. That outflow runs for thousands of years. Then, as the ocean outside climbs, a point arrives where salty water starts creeping in underneath the outflow, sliding along the bottom of the channel. Both directions at once, exactly what Marcili's cork showed him. No dam, no collapse, no wall of water, just a slow handshake between two seas that takes centuries. Their evidence is physical. Look at the seafloor near the southern end of the strait and you find a delta, the fan of sediment a river builds where it dumps into open water. That fan is made of material that came out of the Black Sea, and it was built up around 10,000 years ago, before the supposed flood. A delta like that gets constructed slowly by steady flow, so water was already leaving through that channel, calmly, long before anything was supposed to break. Then they went after the strongest piece of the flood argument, the sudden appearance of Mediterranean shellfish in the mud. Their explanation goes like this. Salt water starts creeping in along the bottom. It slowly replaces the fresher deep water in the basin, and that takes time because a sea is a big thing to swap out. For a long stretch, the shallows are still too fresh for Mediterranean creatures to survive. Then the salinity finally crosses their threshold, and they colonise the shelves, which would look sudden in a mud core, a line where they are absent, then a line where they are everywhere. The same evidence. Two completely different stories. That is how this field works, and it is why arguments last for decades. More recent work keeps landing on the calm side. A study of microscopic fossils from cores off the Bulgarian coast tracked the ecosystem through this period and found it shifting gradually from brackish to marine across a few hundred years with no sign of a shock. Other teams have looked at the geology and concluded the catastrophe never happened. The flood scenario is still defended, especially by researchers working the Bulgarian side, who point to their own evidence for a large fast event. So where does that leave you? Honestly, unresolved. The gradual model is winning on evidence right now. The catastrophic version is a minority position that refuses to die, partly because a piece of it may yet be right. And here is why any of this matters to a video about shipwrecks. The date the flood argument fights over is the date this sea became a killer. Saltwater arriving is what created the heavy bottom layer. The heavy bottom layer is what created the lid. The lid is what killed the oxygen. That argument is not really about Noah at all. It is about the exact moment the sea started keeping things. Run the clock forward from that handshake and watch a sea change its nature. Stage 1, the lake. Fresh water top to bottom, alive all the way down, mixing freely every winter. If a boat sank in it, the boat rotted because there was oxygen everywhere. Anything that went into that lake is gone. Stage 2, the salt arrives. Heavy water crawls in along the bottom of the channel and slides down into the deepest part of the basin. It does not blend. It pools. Stage 3, the layers lock. Now you have light water on top, heavy water below, and a boundary between them that no storm can break. The plumbing that Marsili drew in his box is running full time, and it never stops. Stage 4, the suffocation. Everything living in the deep keeps breathing, and nothing replaces what they use. The oxygen drains away, the animals die. The sulfur bacteria take over and start exhaling poison into water that has nowhere to go. Researchers who study the chemistry down there put the arrival of those conditions at roughly 7,500 years ago. The salt kept building for thousands of years after that, and the layering only reached its modern strength about 3,000 years ago. Which is a date worth pausing on, because it means the sea locked into its current setup right around the time Greeks started shoving boats into it. The timing is almost rude. The trap finished forming, and then human beings began sailing over it in wooden ships, in a place notorious for storms, for the next 3,000 years, without a break. Every ship that ever went down in the deep part of this sea after that point is still there. Every single one. Line up who sailed here. Greeks running grain to colonies, Persians moving armies, Romans supplying legions, Byzantines holding an empire together, Vikings coming down the rivers looking for Constantinople, Genoese and Venetians fighting over the trade, Ottomans ruling all of it, Cossacks raiding out of the river mouths, Russians and Turks fighting war after war, steamships, warships, submarines, aircraft. Every one of them lost vessels here. The storms did not care what flag was flying. We have found around 60, maybe a few more. The searchers have covered a patch of seabed smaller than Rhode Island in a sea roughly the width of the drive from New York to Chicago, most of it deep enough to be inside the preserving layer, so the arithmetic is savage. Thousands of ships, possibly many thousands, all intact, all catalogued by nobody. And it gets worse, because it is not only ships down there. The 20th century happened to this sea too, and it left things on the bottom that nobody is eager to find. Sonar does not care what century a target comes from, it just reports edges. So when Ballard's team ran their targets down, the list came back scrambled across 1,000 years. Out of hundreds of sonar hits, only a fraction turned into anything identifiable, and what they identified was a strange collection. An early medieval wreck loaded with jars, a warship from the 1800s, 3 airplanes, and a Soviet destroyer named after the founder of the secret police sunk during the Second World War. That is the pile. A Byzantine merchant and a warplane on the same seafloor, in the same water, preserved by the same chemistry. The 20th century is down there in force. This sea was a war zone twice over. Warships, cargo ships, submarines and aircraft went into it by the hundreds, and the deep ones went into the layer that keeps things, which produces a picture that should make your stomach turn slightly. Steel does rust down there, but hydrogen sulfide does strange things to metal, and the absence of oxygen changes the whole process. Meanwhile, everything organic aboard is protected. The wooden fittings, the rope, the uniforms, the paper charts on the navigation table, the photographs somebody carried in a pocket. Some of these ships went down with their crews aboard, hundreds of men at a time, which turns the poison into something uncomfortable. It preserves without asking permission. It does not distinguish between an ancient jar of honey and a war grave. There is another modern layer nobody wanted, and it is chemical. Since the 20th century, farms across a huge chunk of Europe have poured fertilizer into rivers that all empty into this sea. Fertilizer makes things grow. In water, it makes microscopic plants explode into blooms that die and sink. When they sink, bacteria eat them, and eating burns oxygen out of the water column. You already know what happens when this particular sea loses more oxygen. The dead layer climbs. Scientists measured it. Over 60 years, the depth where oxygen runs out rose from about 460 feet up to about 300 feet. The living part of the sea lost close to 40% of its space in a single human lifetime. For the wrecks, that sounds like good news. A rising boundary means more preserved ships. For everything else, it is a countdown. That thin skin of breathable water on top is where every fish, dolphin, and fishing fleet in the region lives, and it is getting thinner. And beneath it sits the largest reservoir of hydrogen sulfide on Earth, held down by a lid made of nothing but density. Which raises a question people ask in a nervous voice. What happens if the lid slips? The nightmare version goes like this, and you can find it in 100 places online. The poison layer belches. A cloud of hydrogen sulfide rolls out across the surface and across the coast. Millions of people live on that coast. Hydrogen sulfide is heavier than air, so it hugs the ground and it kills fast. There is precedent, which is why the story has teeth. In Cameroon, in 1986, a deep lake released an enormous bubble of carbon dioxide that had been building at the bottom for years. The gas poured down the valleys in the dark and killed roughly 1,700 people in their sleep, along with every animal in its path. Villages died without waking up. That was a lake a few miles across. The Black Sea is 600 miles wide. So, is it going to happen? Here is the honest answer, and honest is more interesting than scary. The scientists who actually measure this sea say the stratification is strong, very strong. Even a brutal winter cannot generate surface water dense enough to punch through. The layers are held apart by a salinity difference, and salinity differences do not care about weather. They also say something more careful. Right now there is no evidence that the oxygen boundary rising has pulled the poison up with it. The depth where oxygen runs out and the depth where hydrogen sulfide appears are related, but they are not the same line, and one does not automatically drag the other. What they do flag is the local risk. If the layering weakens somewhere, even in one region, the balance could tip and the surface water could take a hit. That is a fishery collapse and an ecological disaster. The global horror movie version has no support. The regional damage version is real and already partly happening, so the ships are safe. That is the strange conclusion. Everything that makes this sea dangerous makes it a perfect vault, and the vault is getting bigger. Except the wrecks in shallower water are being destroyed right now, this year, and the thing destroying them is not chemistry. It has engines, it has steel cables, and it is dragging a weighted net across the seafloor at this exact moment. Bottom trawling is simple to explain and hard to look at. A boat drags a net along the seafloor. To keep the mouth open, it uses heavy doors that plough through the sediment. Chains sweep along the bottom in front of the net, kicking everything up so it gets caught. It works. That is the problem. It works on everything. Researchers mapping the shelf off Turkey went out specifically to measure how much trawling was happening there, and the seafloor told them. Trawl scars. Long parallel grooves carved into the mud, crossing and recrossing until whole regions look like a ploughed field. Now put a shipwreck in that field. A wreck in shallow water is already fragile. The oxygen has let the worms eat the hull, leaving pottery and a few timbers, and a shape you can still read if nobody touches it. Then a trawled oar hits it at a few knots and drags. The jars shatter. The pile scatters. The information is gone, and information is the only thing archaeology has. A broken jar tells you almost nothing. A jar sitting in position tells you where the cargo was stowed, how the ship was loaded, which way it landed, how it sank. One pass erases that permanently. The wrecks Ballard found in shallow water sit right in this zone. So do the drowned coastlines. So does whatever is left of the settlements on them. And there is a bitter joke in the geography. The deep wrecks, the miraculous ones, are safe because nobody can reach them. The shallow wrecks, which are already damaged and therefore precious in a different way, are the ones being scraped away. Trawling also stirs the seabed into clouds, which changes the chemistry, which changes the preservation. The damage is not just mechanical. Nobody is doing this out of malice. These are people fishing for a living in a sea whose fish stocks have already been battered by everything else in this story. But it means the clock is running in the shallows. There is a race between archaeologists trying to map the shelf and boats erasing it, and the boats are much faster. Then, in 2022, something happened that stopped nearly all of it. The research, the surveys, the international teams, the robots, the sea closed. Everything in this story depends on a thing that sounds trivial: access. A survey needs a ship. A ship needs to sail somewhere, and somewhere is inside a national boundary, and that boundary belongs to a government that must say yes. Then you need permits, local partners, and permission to fly robots over a seabed that legally belongs to someone. Every project in this story worked that way. Ballard's expeditions were joint efforts with Turkish and Ukrainian institutions. The big survey was Anglo-Bulgarian, tied to the Bulgarian Academy of Sciences and the country's underwater archaeology centre. Those relationships took years. They are the actual foundation, more than any robot. Then Russia invaded Ukraine, and the sea became a military zone. Understand what that means physically. Mines drifting loose, naval combat, drone boats, restricted zones, insurance companies that will not cover a research vessel, governments with more urgent uses for their Coast Guard than escorting archaeologists. Nobody is running photogrammetry surveys through that. There is a grim archaeological footnote here too. The war is adding to the collection. Warships have gone down in this sea in the last few years. The most famous one, a Russian cruiser, sank in water deep enough to be inside the layer. So the sea is doing what it always does. It is taking modern ships and beginning to keep them on the same seafloor as the Greek trader, under the same chemistry, for whoever eventually comes looking. Meanwhile, the wrecks already found are simply waiting. The mile-deep Greek ship has been sitting untouched since 2017. Its hold sealed, its cargo unread. In water nobody can currently reach for reasons that have nothing to do with technology or money. The Byzantine wreck off Turkey has been waiting since the last expedition to it. Its construction methods still buried in the mud, still holding the answer to how ships change forever. They are patient. They have waited 24 centuries. They can wait out a war. And in the meantime, one number should keep you awake. The searchers have covered a fraction of 1% of this sea. Do the arithmetic slowly, because the arithmetic's the whole payoff. The Black Sea covers about 160,000 square miles. That is larger than the state of California. Roughly 90% of its volume is in the layer where nothing rots, and most of its area is deep enough to qualify. People have been sailing across it for 3,000 years, at minimum, in wooden boats, on a sea famous for storms that build out of a clear morning. Total wrecks found and documented in the preserving layer, across every expedition by every team in history, somewhere around 60 to 70. Total seabed properly surveyed, about 770 square miles from the big project, plus a scattering of smaller areas. That is a fraction of 1%. So take those 60 ships and understand what they represent. They are not the collection. They are the first handful pulled from a random patch that somebody happened to scan for an entirely different reason. Multiply out. Even conservatively, the number of intact ancient and medieval ships sitting in the dark right now runs into the thousands. And here is the thing that separates this from every other archaeological frontier. There is no decay clock on most of it. A tomb robbed is gone. A site bulldozed is gone. A wreck in the Mediterranean is being eaten right now, tonight, while you listen to this. The deep Black Sea is not losing its collection. It is holding it, exactly as it was, waiting for us to get our act together. Think about the specific things down there. A Roman grain hauler with the grain still in the hold. A Viking boat that came down the rivers and never made it home. A Genoese trader from the years when a plague was moving along these exact routes. Ships from cultures whose vessels have never been seen, only described in documents by people who never drew a picture. And under all of it, the drowned coast. Hundreds of miles of prehistoric shoreline, partly inside the preserving zone, holding the wooden world of people who left us almost nothing. Every one of those is a story with a beginning and an end and no middle, because the middle is a ship on a seafloor that nobody has visited. There is one more thought, and it is the one that turns this whole thing around and points it at you. Everything you have seen down there was found by accident. Look at how each discovery in this story actually happened. An engineer wrote down a hunch in 1976 and nobody tested it for 24 years. A famous explorer went looking for a drowned coastline, ran out of season, made one last sweep, and found a Byzantine ship standing upright with rope on its mast. A team of geologists went looking for the same coastline on a different shore, scanning mud for evidence about sea levels, and stumbled into 60 ships. They called it a bonus. The oldest intact ship ever found by human beings turned up in the final phase of a mission that was never about ships. Nobody set out to find any of it. Every single one was a side effect of somebody asking a different question, which tells you something uncomfortable and thrilling at the same time. We're not searching this sea, we're tripping over it. And the searching that has been done was done with robots built for oil pipelines, on borrowed schedules, with whatever funding could be scraped together, in a region that keeps closing for war. Now think about what changes next. Robots are getting cheaper and smarter every year. Machines that map the seafloor without a crew are already working. Software finds shapes in sonar that a human eye would skip. The cost of looking is collapsing. At some point, somebody will survey this sea properly. Not a patch. All of it. When that happens, 3,000 years of human history comes back at once. Not as fragments, as ships, with their cargo, their rope, their tools, and whatever the crew was carrying when the weather turned. That is the strangest part of this whole story, and it is worth ending on. We think of the past as gone, burned, buried, decayed, rewritten by people with agendas, surviving only as chips of pottery and copies of copies. And then there is this one sea, this one accident of geography, where a narrow strait and a heavy layer of salt built a room that time cannot enter. Everything that fell into it is still falling, in a sense, still mid-voyage, still carrying its cargo toward a port that stopped waiting a long time ago. The lights are off in there. They have been off since before Rome. Somebody's going to turn them on. If you made it this far, you already know what to do, like subscribe and tell me in the comments what you think is sitting in that sealed hold. I have a guess. I hope I am wrong, because wrong would be better.